Okay, 3-5 is symmetry. We are going to identify types of symmetry. So a figure has symmetry. For rigid motion can map the figure onto itself. Reflectional symmetry. Is a symmetry for which a reflection maps a figure onto itself. The line of reflection is called the line of symmetry. And it's kind of like reflection. Just reflecting something over the line, half of the shape. A figure has rotational symmetry. If you can spin it and it doesn't look like it's moved. Okay? So if we look at these, what transformations map each figure onto itself? We have reflection. If I folded it here, it would look the same on both sides, and here if I did it here. So we have two lines of reflection. And we also have 180-degree rotational symmetry. If I spun the shape from here to here, oops, about missed it. Okay. B has reflectional symmetry here. I could draw a line there and it looks the same, but it does not have any rotational symmetry. So with this next, how many lines of symmetry does a regular hexagon have? And if we draw a line all the way around to 3, so it has 3 lines of symmetry. Let's try these in class. Okay, so rotational symmetry. All right, so the way we do rotational symmetry is we look. I see 3 points on this triangle that I could rotate it to. 1, 2, 3. So what we're going to do is we know 360 degrees all the way around divided by those 3 points means that each one of those rotations is 120 degrees. Or if I add 120 degrees to that, I could have gone 240 degrees, which is like putting it from here to here. This parallelogram, I could go from here to here, and it would look the same. So 360, that means there's 2 points, 1, 2, which is 180 degrees rotational symmetry. If there's 180 degrees rotational symmetry that maps the figure onto itself, it is called point symmetry. Okay, it's the same thing as 180 degrees. So here we have 4 points. So I'd say 360 degrees divided by 4 is going to give me 90. 90 plus 90 would be 180. Plus 90, let's do 70. So I could rotate that 90 degrees, I could rotate it 180, and I could rotate it 270 degrees, and you would never know that I rotated it. This shape has 180 degree rotational symmetry. What type of symmetry does each figure have? So if I look at that, I could draw 1, 2, 3, 4, 5 lines of symmetry, right? So it has 5 lines of symmetry, line symmetry. And then I would say 360 divided by 5 gives me 72 rotational symmetry, 144. And then add 72, 16, and 288. So I add 72 to this until I get to 360, and then I stop. So, and then this shape, there is no lines of symmetry. There's no symmetry that I can draw and it looked the same on both sides. But I could rotate it from here to here. So it has 180 degrees rotational symmetry. All right, so this says, what symmetries does a square have? Well, it would have 4 lines of symmetry. And of course, it would have 90, 180, and 270. And in class, I'll show that to you if you need me to. Let's see, we are going to skip that one. And that's it.